Is R1234yf gas, used in modern automotive air conditioning systems, really dangerous? Let's start by clarifying that R1234yf refrigerant gas is highly efficient, safe, and classified as mildly flammable, under category A2L. However, as we will see below, its safe use and operation essentially depends on the system's design and subsequent maintenance tasks. R1234yf does not spontaneously explode, but if an air-gas mixture is formed in flammable proportions and exposed to an ignition source, it can burn. For this reason, in original vehicle designs, air conditioning system pipes are placed away from components such as the exhaust manifold, turbo, or collector, where temperatures exceed 400 degrees Celsius 752 degrees Fahrenheit. This is crucial because, in the event of a crash or system damage, pressurized gas mixed with compressor oil can be released as a mist. If this mist comes into contact with an extremely hot surface greater than 400 degrees Celsius 752 degrees Fahrenheit, combustion can occur. The use of incorrect or contaminated oils also increases the risk. R1234yf requires special PG-type oils. If R134A oil or other incompatible fluids are introduced, lubrication capacity is reduced, and hot spots can be generated within the system. Furthermore, the presence of air in the system when charging the gas or starting the compressor can cause heat by compression, raising the temperature enough to ignite the flammable refrigerant. Air also alters the pressure balance. Unlike refrigerant, air does not condense, which generates a pressure increase, especially in the condenser. Now let's look at the protection and prevention measures in R1234yf air conditioning systems to avoid accidents. A. The location or models of the vehicle's original pipes must not be modified. The original air conditioning system pipes are designed to be kept away from critical areas such as the exhaust manifold, turbo, or catalytic converter. B. In many vehicles using R1234yf, high-pressure lines are encapsulated within plastic or metal ducts, including insulating layers. These components must not be modified. C. Some system pipes also incorporate fire retardant sleeves or reflective jackets to block radiant heat. These components must not be modified. D. Metal shields are placed between the engine and the air conditioning lines. These sheets, generally made of aluminum or stainless steel, block direct radiation heat and can reduce the temperature of the protected area. E. Some factory original vehicles are equipped with relief valves or directed rupture points that expel R1234yf gas in the opposite direction of the exhaust if overpressure occurs. This prevents the gas from being projected towards extremely hot components. F. Although the exhaust system does not cool down, some sections may have thermal blankets, especially near sensitive components such as cables, sensors, or hoses. These components must not be modified. G. For maintenance tasks, never use compressed air or oxygen mixtures for cleaning or leak detection. Only inert gases such as dry nitrogen should be used. H. R1234yf uses specific synthetic oils, PEG or POE, compatible with its chemistry and mild flammability. Compressor oil can ignite if there is a leak. It is released as a fine aerosol, which facilitates ignition. Ignition tests have shown that, although the gas alone does not always ignite, when mixed with oil and touching hot surfaces, it burns immediately. Never reuse oil that has been exposed to air, as it absorbs moisture and loses properties. 1. Perform a deep vacuum before charging the gas to remove air and measure it with a vacuum gauge. The vacuum obtained by the vacuum pump must be less than or equal to 500 microns. J. Once 500 microns of vacuum is reached, close the manifold gauges, turn off the vacuum pump, and allow a minimum vacuum time of 20 to 30 minutes. If the system is completely sealed, the vacuum value shown on the vacuum gauge must be maintained.